In the previous video, we learned about fibrations and how to construct terms in a total space using the transport function. But in this video, instead of constructing points in the total space, we will construct paths. But first we must learn how to construct paths between pairs. Suppose we had the pairs AB and CD inhabiting the type A times B. We can then speak of a pair of paths PQ inhabiting the type A equals C times B equals D. We can then apply the function pair equals to our pair of paths to get a path between pairs. But what about dependent pairs? Well, suppose we did have the pairs XU and YV inhabiting the sigma type sigma PA, where P is some type family. Note that we can't speak of a path between dependent pairs in the same way we did with non-dependent pairs, since U and V are not of the same type, and thus we can't speak of the equality type U equals V. So here's what we do. We construct a pair of paths WR, where W is a path from X to Y and R is a path from P star U to V. We can do this since P star U is a term in PY. We can then apply the function pair equals to our pair of paths to get a path between dependent pairs. We can now construct paths in a total space. Let's see how it is done. Suppose we wanted to find a path between the terms XU and YP star U in the total space. If we were to construct a path between these pairs in the same way we constructed a path between XU and YV earlier, we need only construct a pair of paths in the following sigma type. For the first term, we already have the path P from X to Y, and for the second term, we pick the path Riffle P star U. We can then apply pair equals to construct a path from XU to YP star U. Let's call this path lift UP. We thus have a function that, given a path P from X to Y in the base space, we have a path lift UP from XU to YP star U in the total space. Similarly, given a term V in the fiber PX and a path Q from X to Y, we can construct the path lift VQ such that it lies above Q. We now know how to lift paths in homotopy type theory. Thanks for watching.